Hi, this is a short introduction on how to use NCS to manage a network of Juniper devices. NCS is a multi-vendor configuration management solution targeting network devices and firewalls and network equipment in general. We're especially good at configuring Juniper devices because we integrate natively with the Juniper netconf interface. At the core of NCS is its configuration database. In contrast to more simplistic config management solutions, we don't just store the config files as text blobs. We get the configuration from the devices and we ingest it and fine-grained represent the device configuration within the database. Then network engineers can use our CLI or web UI to fine-grain manipulate the representation of the Juniper devices and then committing that as a transaction towards the devices. The database is model driven, meaning that we have device models, and the device models in the Juniper case is directly rendered from the Junos schema. So this means whenever you upgrade your Junos, we can get the schema from the Junos and we will render the device models, which will update the database schema. At the same time, it actually updates all the northbound API, so there will be no feature lag between the upgrade of the network and the user interfaces of NCS. Everything is auto-rendered directly from the device models that you get from your Juniper. Also, NCS can manage services, so you can use NCS to provision services like BGP peers, VPN, firewall rules. In this case, the database will contain the service instances, and when you provision or change those, NCS will automatically calculate the changes, apply it to the device data models, which then is applied to the network devices. However, in this first demo, I will focus on using NCS as a power tool for managing Juniper devices. So in this demonstration, I will show you how to use NCS to manage a network of Juniper devices. I will move between the NCS web UI and the NCS network-wide Juniper CLI, which is in front of you now. When I start the demo, I have configured NCS with the IP address and the authentication information for the devices in the network. That's all. The configuration database in NCS, apart from that, is totally empty. And first thing to do is to be able to get the configuration from the devices and ingest it into the database. So NCS supports synchronization with the network in both directions, and you can push the database in NCS to the network in case you would like to restore a global config, but in this case we're interested in getting the configuration. So synchronize the configuration from the devices into NCS. And in contrast to more naive config management systems, we don't just grab the config files and store them in a database as blobs. We represent the configuration data fine-grained so we can inspect and manipulate every piece of the information. Let's move to the network CLI to check on that. Since I have the information in the NCS database at this point, I can do operations across devices because we can display from the database. So in this case, I ask NCS to show the configuration of all the devices. I don't direct the command to a specific device here, and I would like to see the interfaces to a certain depth. So we see here that I have these interfaces on Juniper 1 and I have these interfaces on Juniper 2, and the display level 5 limits the depth. If I'm interested in a specific interface across the devices, I can ask NCS to display that. So in this case, I asked for the fast Ethernet interface, and I see the information for Juniper 1 and Juniper 2 here in one display. And the NCS CLI as well as the web UI supports all the features of Junos. We render the whole management solution from the Junos schema. So whenever the schema is updated, our network CLI is updated and our web UI is updated. So this means that if you do a tab completion or a question mark in the NCS CLI, you will actually be able to see all the capabilities that are available on the routers. So asking for what can be configured, and here you see all the features that can be configured on a Juniper device. So now we can start to show some configuration scenarios. I will do some simple settings of the SNMP parameters for both of the devices. Let's first do it device per device. So I'm navigating down in Juniper 1 into its config and into its SNMP settings, and assume I would like to change the system name here to represent its name. So I'm changing that to Juniper 1. Here I started a transaction, but this is still local to NCS. Whenever you do modifications over the NCS CLI or the web UI, you start a transaction, and not until you do a commit in the CLI or save in the web UI will the changes be sent towards the network. So this is a local change so far. Let's continue and do the same for Juniper number 2. So what will be the changes? I will update Juniper 2 and Juniper 1 with the new values of the sys location. So I can save, and save is transaction. So again, this means that if any of the two devices fail, nothing will happen in the network. NCS always keep the network in a consistent state. So let's apply it. So now things were changed on the devices, transaction safe. This also means that as a network engineer, you can always bring up the rollback file and do manual rollback. So all the changes you do in the network are saved in network-wide rollback files. So here is the rollback of the latest change, and it will delete the system name of Juniper 1 and delete the system name of Juniper 2 again as a transaction. So I'm loading that. What will be the changes? It will delete those two values so we can commit it. So, operation undone, network-wide. Configuration changes can also be simplified by using device groups and device templates. So, a device group lets you group, let's say, all the core routers in one group or arbitrary groups. And templates are configuration snippets that you can apply to a device or a group of devices. So I have prepared two things here. Let's look in the network CLI. I have prepared a device group which I call all, that contains Juniper 1 and Juniper 2. I also have prepared a configuration template that sets the system location to the value the location. So I have a group and I have a configuration template. Let's go back to the web UI. We have device groups, the group all. See, it contains Juniper 1 and Juniper 2. Let's apply a template. Which template? Bring up the templates here. Check that one. And perform action. Again, this starts a transaction which calculates the minimum diff which is sent to the network when I explicitly say save or commit. So what will happen? So you can actually also view this as an audit function. What is the diff between this template and devices in the group? This is the diff. None of them have the value, so NCS will actually write those two values to the network, and we can save that one, meaning commit to the network. Operation saved, transaction done. Now, this final part of the demo will show you how to set up internal BGP, as I mentioned. I have now logged in to one of the Junipers, and I did a show BGP summary, and as you see, BGP is not running on the device yet. So let's set up the internal BGP. I will do that over the CLI. So first, create the BGP configuration on Juniper number 1. Do the same for Juniper number 2. So it's creating my network here for Juniper 1 and the same for Juniper 2 commit. Now that configuration is sent to both devices as one single transaction, and apart from the BGP we need to set up the backbone interfaces across both Junipers as well. And the diff in this case will be the interface on Juniper 1 and the interface on Juniper 2 commit. So, did this work? We can move back to the Juniper CLI on the device and do show BGP summary. And we see that BGP is up and running. So this concludes the demo. Thank you.